I probably could have done with starting that going when I was explaining the previous things I did, but never mind. So I'm going to make a brief video here just explaining a few things and also sort of showing yourself a few other things about Miro. So what I want to do then is I get a periodic table. So I click on Google Image Search, the little G. If I type in periodic, can't spell, periodic table, what I get whenever you search periodic table, you get lots of different things, lots of different colourful periodic tables. Unfortunately, quite a lot of them are not much use. If you type in GCSE right afterwards, you always get better results, and you choose the one that's just in black and white, and it'll always be the one that you want. So one of the things that we learn about the periodic table when we first started learning about it is that you got the mass number and the atomic number. So you feel fairly familiar with what the atomic number and the mass number is, yes? Cool. So you probably know, therefore, that the mass number is the number of protons plus neutrons, and the atomic number is just the number of protons. What you may or may not know is the atomic number is what defines what element it is. So in other words, if an atom has 6 protons, it is carbon, no matter what else you do to it. You can change the number of neutrons and the electrons, it's always going to be carbon. And if you take away a proton, it's now become boron, and if you add a proton, it now has become nitrogen. That is key to understanding things like isotopes and basically all of chemistry. And a lot of people don't, that sort of point gets glossed over. But that's the first thing. And as I said, the next thing was that the number of protons and neutrons is the mass number, right? That's fairly, everybody accepts that. But it's not quite true. It's usually true. It's not quite true. And we'll notice why it can't be quite true when we look at chlorine. Because chlorine has a mass number of 35.5, which is a bit weird. How could you possibly have a mass number of 35.5? I'm going to pause the video. I want you to use a text tool by tapping T on your keyboard or choosing T on the left. And I want you to write your explanation or your guess why you think chlorine has a mass number of 35.5, or write down why it would be confusing that chlorine has a mass number of 35.5. Either of those questions you can answer, or both. So you're on the right track. I mean, it would actually suggest that chlorine would have 35.5 take away 17 neutrons, right? However, so that would be, I have to do it quickly in my head now whilst on video, 17.5, no, 18.5. 18.5 neutrons. It seems as if chlorine has 18.5 neutrons. Now, it doesn't. That isn't the explanation to this mystery. The actual explanation is that there are 2 versions of chlorine, or 2 types of chlorine, or 2 isotopes of chlorine. Okay, and one isotope of chlorine is, I think I want to use a different color than that. One isotope of chlorine is, so it's still 17 because it's chlorine and it can't have any other number because otherwise it wouldn't be chlorine. 1 second. But so there's one type which is got a mass number of 35, and there's another type which has not got a mass number of 36 but a mass number of 37. Okay. The thing is, there's actually 25%. If you get a load of chlorine atoms, there's 25% of them. I've got that the wrong way around. It's 75%. 75% of that one in a standard sample, and 25% of that one. So what it does is we take the average mass number and it averages out to be, as you can see, because the larger amount is on this one, so the average shifts towards that side, and the average is not 36 but 35.5. Okay, now and so we can say, it's the average amount of the average mass number, right? But it's not really quite like that either. It's more like the mass number is well, and I want, certainly for this lesson, I want you to think about it as it's the grams in 1 mole. Okay? It's the grams in 1 mole. Okay? Now that bit, nod if that bit is familiar to you already in terms of moles. So still a bit fuzzy about that. So what we need to now think about then is what is a mole, and there's a video I did on that in that series earlier on. I don't know if I'm going to explain it better now or better then, but we'll see how well I explain it now. It comes down to the number called Rutherford's number. Rutherford's number? No, Avogadro's number. Avogadro's number. Sorry, Rutherford was the guy that sort of constructed the periodic table, or one of the people at least. Avogadro was the one who came up with his special number. I'm gonna have to just quickly search it because I think it's 6.002 times 10 to the 34. But let's have a look. Avogadro's number. Yeah. Oh, 23, not 34. Yes. Okay, cool. So I'm just going to copy that down here. Oh, wait a second. Okay, cool. So Avogadro's number is this number here. And that should say to the power of. Use that, which means to the power of. We can just simplify that to be 6 times 10 to the power 23. Now, are you familiar with standard form? Standard form, okay. So we know if it was just 6, it would be 6, then 23 zeros. So what does that number mean then? So do you have a general idea of what that number means, or what Avogadro's number is, or shall I explain it, or do you want to have a go at explaining it yourself? So option A, I explain it myself, or option B, you have a go at explaining it yourself first. Okay, so basically, what Avogadro's number is it's saying this is the amount of, well, it's saying particles. We'll use the word particles. I'm not going to use the word atoms or molecules because particle is being used to describe either whether it could be atoms or whether it's molecules. It's a more general word. The amount of particles in 1 mole. Okay? So the definition of a mole is it's just this many particles or something. So in other words, 1 mole of carbon is equal to this number here, carbon atoms. That is what 1 mole of carbon is. And of course, if it was 1 mole of oxygen, well, let's stick to non-molecular substances for a start. So 1 mole of zinc would be that many zinc atoms. 1 mole of copper would be that many copper atoms, and so on. Okay. It just so happens, well, I say not just so happens, the number was chosen very specifically because the mass number ends up being, it turns out that if you have that many carbon atoms, the mass of 1 mole of carbon is equal to 12 grams. That's very handy, right? That's why they chose that number. So they can weigh out very carefully 12 grams of carbon and be fairly confident that that's how many atoms you have there on your in your beaker or whatever it is. So that's the definition of a mole. Yeah. So there is one thing worth saying here is if I said one, because this can definitely cause confusions later on. 1 mole of oxygen is, if I got that on my clipboard, I do. Is that many oxygen, but not atoms, molecules, because oxygen goes around as a molecule. Okay, it exists as molecules. So what would be the mass? In fact, I'll see if you can write the mass of 1 mole of oxygen. I will do that, and then you can edit my word box and write what you think 1 mole of oxygen would be. So if oxygen went around as atoms, then it would be 16, and the unit would be grams. So 16 grams. So if I actually said to you a mole of oxygen atoms, then the answer would be 16 grams. But I'm saying a mole of oxygen, and because I've not said one way or another, you have to assume it's oxygen molecules. Oxygen molecules are O2. So that means each oxygen molecule has 2 oxygen atoms in it, which means there's going to be twice as many oxygen atoms in 1 mole, which in other words means it's going to be 32 grams. So the molar mass of oxygen, which means the molar mass of oxygen molecules, is 32 grams. Okay, so let's just amend that.